is where the journey of pure gold begins, carved from the earth, one bench at a time. Here, science and experience decide which rock becomes waste and which will yield gold.
Controlled energy is carefully measured into every hole, storing the force that will break the rock free.
With every connection checked, hundreds of hidden charges are linked into a single precisely timed event. In a matter of seconds, solid rock is shattered into fragments small enough to move and process.
Blast clear.
Heavy steel smooths the chaos of the blast, preparing a stable working face for the next machines. With the face prepared, the shovel takes its position to tear the loosened ore from the bench. Each scoop lifts raw, gold-bearing rock from the earth, beginning its journey toward the refinery. Giant haul trucks roll into place, ready to carry the broken ore toward the heart of the operation. Ton after ton of rock is dropped into steel beds, each load a dense concentrate of hidden value.
Even here, experts conferred the ore grade, ensuring that only rock rich enough in gold joins the flow.
At the pit floor, every load is directed, sending rich ore one way and barren rock another.
One by one, loaded trucks fall into line, forming a steady stream of ore headed out of the pit. Hundreds of tons of rock ride on each tire, translating raw engine power into steady, unstoppable movement. From deep within the pit, ore-laden trucks begin their slow ascent toward the refining complex on the rim. Loaded with freshly blasted ore, the trucks now carry the Earth's broken rock toward the machinery that will unlock its gold. Emerging from the pit, each loaded truck now lines up with the industrial complex that will turn rock into pure metal. On the surface, a dedicated haul road links the open pit directly to the crushers and conveyors of the gold plant.
Every loaded unit is weighed and logged, keeping tight control over how much ore flows toward the refinery.
Cleared from the scale, the ore trucks head straight for the run-of-mine pad, where rock first meets the plant's hungry steel. Here, a steady queue of trucks feeds the coarse ore hopper, keeping the crushers supplied without interruption. Guided with care, the loaded truck edges back until its tailgate hangs just above the hungry opening of the ROM hopper. In seconds, an entire truckload of ore is dropped into the hopper, trading diesel power for gravity and steel. The Grizzly strips out oversized blocks, letting only correctly sized rock drop toward the plant's first conveyors. From the hopper's throat, a rugged apron feeder meters out the ore, turning a chaotic dump into a steady, controlled flow.
Now consolidated on a belt, the ore begins its mechanical journey from the ROM pad toward the heart of the processing plant.
Suspended on trestles, the overland conveyor carries ore across the busy plant yard, untouched by wheels once it leaves the trucks.
As the conveyor passes through the wall, the ore finally crosses from open yard into the enclosed world of the processing plant.
Elevated above the ground, the climbing belt lifts the ore straight into the upper levels of the processing plant.
As the conveyor passes through the wall, the ore finally crosses from open yard into the enclosed world of the processing plant.
Inside the plant, the conveyor hands its burden into a coarse ore bin, buffering the flow between the pit and the crushers.
From the bin's base, controlled feeders pull ore back onto belts, delivering a measured stream toward the first crushing stage. A final short conveyor delivers the ore directly into the primary crusher, where transport gives way to size reduction. With the ore now crossing this threshold, the transport phase ends, and the true industrial heart of the gold plant begins. From this single housing, the primary crusher anchors a sprawling complex built to turn ore into pure gold.
From above, the refinery looks like a living machine, every building and conveyor feeding the same golden objective.
Purity and separation mark the threshold where the outside world ends and the gold plant begins.
Sensing my flutter.
Every person and every shift is logged at the gate, ensuring that the complex inside runs under strict control. Inside the change house, miners become plant operators, armoring themselves against noise, dust, and steel. Moving from the yard toward the towering crusher block, the crew steps deeper into the factory's mechanical heart. With every step up the vibrating stairs, the raw noise of the crusher grows from a distant rumble to an enveloping presence.
From this quiet glass box, operators watch numbers and graphs that mirror the violence of steel and stone outside.
Just outside the control room, the catwalk brings boots and eyes into direct proximity with the plant's heaviest equipment. From this vantage, the relentless feed stream is felt more than seen, a reminder of the constant load the plant must tame. A secured access door marks the transition from crushing to the first stages of cleaning and sorting.
Inside the screening building, vibration and noise rise, signaling where the plant begins to separate and clean the crushed ore.
Higher inside the structure, each level brings the crew closer to the vibrating decks that will sort and wash the ore. At this level, enclosed but unmistakable, the first cleaning and sizing equipment shudders relentlessly under full load.
Just beneath the walkways, crushed rock begins to spread and churn, preparing to be sorted and rinsed by the shaking decks. From above, the separation is already visible, with water and motion beginning to strip fines from coarser fragments.
Here at the deck's edge, the freshly crushed ore first meets the shaking surfaces that will separate and wash it for further refining.
At this close range, the factory's first true act of refinement is revealed in the restless motion of rock, water, and steel.
On these vibrating decks, water and motion start the first precise separation of the crushed ore.
As the deck thins out, only the coarsest fragments remain to roll over the lip and continue on a separate path.
Oversized pieces peel away from the main flow, funneled down steel chutes to be crushed again. Carried away on a dedicated belt, the coarse fraction begins its own loop back through the crushing circuit. Before recrushing, powerful magnets strip stray steel from the flow, protecting downstream machinery from hidden hazards. Stripped of dangerous steel, the oversized rock is ready to be fed safely back into the crushing circuit.
While coarse fragments go back inside for more crushing, a smoother, correctly sized stream leaves the building, ready for the next level of sorting.
This more uniform stream is now guided toward the mills, but first it passes through additional stages of cleaning and inspection.
Human eyes and hands still play a role here, plucking stray wood and plastic from the ore stream before it reaches the grinding circuit. Automated samplers carve small, representative slices from the stream, preserving evidence of ore quality for later analysis. Each sample bag records a moment in the ore's journey, tying the physical stream to precise measurements yet to come. Cleaned and sized, the ore is now lifted toward the mill building, where the real reduction work will begin. Inside the gallery, the conveyor penetrates the mill building, carrying its burden toward large bins that buffer and steady the feed.
A final surge from the belt drops the cleaned ore into a feed bin, creating a rolling reservoir between the conveyors and the grinding mills.
At the bin's base, gravity squeezes the ore toward controlled outlets, where rugged feeders pull it into the final approach to the mills.
Here, variable speed feeders transform the bin's slow, compressive flow into a smooth, metered stream toward the grinding circuit.
Gathered once more onto a single belt, the fully cleaned and sized ore now approaches the massive mills that will grind it down. At the mouth of the feed chute, the cleaned ore stands at the threshold of the grinding mills, ready for the plant's core processing stage to begin. At the feed chute, dry rock meets water and steel, entering the mill that will grind it down to liberation size. Just beyond the hatch, rock and steel collide in a churning cascade, beginning the core act of size reduction.
Outside, the mill turns with measured power, driving the constant internal collision of ore and grinding media.
At the discharge, a rotating trommel splits the mill's output into fine slurry for the process, and coarse pebbles for recrushing.
Ground fines fall into slurry, while stubborn pebbles are peeled off and sent on their own loop for another round of crushing. On their narrow belt, these oversized fragments are delivered straight to a dedicated crusher that will break them back into the grind.
In this enclosed chamber, hard pebbles are forced through a narrow gap, shattered into sizes that can rejoin the slurry stream.
Once broken down, the recycled pebbles vanish into the same turbulent sump that feeds the plant's classification stage.
High-pressure pumps lift the ground slurry from the sump, forcing it up into a bank of hydrocyclones that will split fine from coarse.
Spinning violently inside each cone, the slurry is split. Fine, liberated particles overflow to the next stage.
Fine overflow moves onward toward extraction, while the heavier fraction is peeled off, sent back for another pass through the grinding circuit. Coarse underflow from the cyclones drops into the ball mill, where dense grinding media will reduce it to the fine size required for gold liberation. From the ball mill discharge, finely ground slurry collects in a pump box, ready to be pushed once more through classification. In the pre-leach thickener, fine solids settle while excess water is skimmed away, concentrating the slurry for efficient extraction. Concentrated underflow leaves the thickener through powerful pumps, carrying a dense, leach-ready slurry toward the chemical extraction circuit. Along the pipe rack, thickened slurry meets carefully metered reagents, creating the chemically primed stream that will enter the leach tanks.
As this thickened, reagent-charged slurry spills into the first leach tank, the plant's main transformation stage.
Here in the first leach tank, crushed rock becomes a reactive slurry, stirred constantly as chemistry begins to free microscopic gold.
pH and potential are watched continuously, keeping the cyanide solution in the narrow window where gold can most effectively dissolve. In this train of vessels, contact time is stretched so the cyanide can slowly leach gold from every grain of finely ground ore. Metered pumps feed cyanide and lime in carefully controlled doses, sustaining the chemical environment that pulls gold atoms into solution. Injected air and oxygen help drive the electrochemical reactions, keeping gold in solution so it can be captured downstream.
After sufficient leaching time, the gold-bearing slurry passes into CIL tanks, where activated carbon will capture the dissolved metal.
Fresh activated carbon is dosed into the first CIL tank, providing millions of tiny surfaces for dissolved gold to cling to. Interstage screens hold the carbon back while letting slurry pass, keeping the precious metal-laden granules circulating within the CIL train.
Treacle dent. As slurry advances down the line, carbon becomes increasingly rich in gold, eventually pumped out as loaded carbon.
Loaded carbon is separated from slurry and rinsed, leaving clean, gold-bearing granules ready for washing and chemical stripping. In the acid wash column, impurities are stripped from the carbon surface, preparing it for the high-temperature elution that will remove the gold itself.
Hot caustic cyanide is pumped through the loaded carbon bed, pulling gold off the granules and into a concentrated strip solution.
The pregnant eluate tank gathers a clarified, gold-laden solution, now ready to give up its metal in the electrowinning cells.
In the electrowinning cell house, electric current will coax dissolved gold out of solution and back into solid metal on steel plates.
On the steel cathodes, dissolved gold atoms are reduced and begin to form a tangible, metallic layer that can be harvested. Once sufficiently loaded with metal, each cathode is lifted from the cell and moved toward a separate area where its gold-rich coating will be recovered.
At the wash bay, a simple button press and digital recipe bring automation into the final stages of extraction.
Behind every simple touch of a button, layers of logic and automation coordinate valves, pumps, and power with exact timing.
Inside the PLC enclosure, digital inputs and outputs translate field devices into lines of code that orchestrate each automated cycle. Data from every motor, valve, and sensor is funneled through industrial switches and fibers, converging on the plant's central brain.
Beyond the noise and dust, a climate-controlled room of screens and servers oversees every moving part of the gold factory.
On a single screen, the whole flow from blasted ore to dissolved gold can be seen, each icon pulsing with live data.
Advanced control algorithms continuously nudge feed, water, and speed, squeezing maximum performance from the grinding circuit without crossing critical limits. Live camera feeds bring the reality of grinding steel and rock into the calm glow of the control room's digital dashboards. Outside the screens, field engineers stand beside the same machines, verifying that the readings in the control room match the heartbeat of steel and bearings. Permanently mounted sensors feed vibration and temperature data into the monitoring system, turning the mill's subtle tremors into actionable warnings. In the MCC, intelligent drives and starters feed status and diagnostics back into the plant network, blending raw power with detailed feedback.
Redundant servers and controllers quietly log every reading and action, keeping the plant's nervous system online and recorded around the clock.
High-value areas are watched and logged in real time, ensuring that only authorized boots enter the spaces where bullion will soon appear.
In the secure gold room, even the furnace and casting line are run from behind glass, guided by interlocks and digital recipes rather than manual ladles.
Behind the icons and set points lies a real furnace and carousel, waiting for every safety condition to align before a gram of molten gold can move.
Sensors, cylinders, and encoders surround the glowing crucible, choreographing the precise movements that will suit.
Dedicated automation panels in the gold room tie each actuator and sensor into the same control philosophy that runs the crushers and mills outside.
On a single digital board, the plant's performance is reduced to numbers and colors, with the gold room glowing as the final link in the automated chain.
With automation confirming every condition as ready, the plant stands on the edge of its most precise act, casting raw value into finished bars.
Under tight interlock control, the tilted furnace releases its first luminous stream of molten gold into the waiting mold.
Under automated control, the carousel steps each mold under the steady pour, turning a single molten stream into a full batch of identical bars.
As the molds travel away from the furnace, the white-hot metal stiffens and darkens, locking its mass into the familiar shape of a bullion bar.
Once sensors confirm the metal has set, each mold is locked under a press that will push the newly formed bar out into the open. Under slow, powerful pressure, each mold releases a solid gold ingot, still hot enough to glow faintly as it hits the cooling deck. Lined up on stainless racks, the hot ingots shed their heat until they are stable enough to be handled and finished.
Each bar is trimmed of its casting sprue and stubborn flux, leaving a clean blank ready for marking and refinement.
Within the brushing booth, fine abrasives even out the surface, preparing each ingot for precise weighing and official marking.
With a single downward stroke, each ingot is transformed into a numbered bar, its purity and origin permanently struck into the metal.
Up close, the finished markings and subtle textures reveal both the precision of the die and the dense reality of nearly pure gold.
Automated cameras and laser gauges confer dimensions and markings, ensuring each bar meets strict visual and geometric.
Proved bars are nested into labeled trays, each batch tagged with its origin and weight, before being wheeled toward deeper quality checks.
Tiny sections and shavings are removed from selected bars, providing representative material for the assays that will certify purity.
With samples sealed into the pass-through, the finished bars now wait while the laboratory conforms that every batch truly meets its 24-karat promise.
In the sealed assay lab, tiny shavings of gold arrive under controlled transfer, ready to be logged into the refinery's memory.
Each sample is scanned into the lab's information system, tying every shaving of metal to a specific bar and batch. Under the sensitive eye of the balance, tiny portions of each sample are weighed out with precision before they enter the crucible of fire assay.
Flux powders are blended with each weighed sample, preparing the tiny charges for fusion in the scorching heart of the assay furnace.
One by one, the charged crucibles vanish into the furnace, where heat will melt metal and flux into a single glowing fusion. From the furnace, molten slag is poured away, leaving behind tiny beads of metal, concentrated snapshots of each bar's gold content.
The tiny metal beads are parted and dissolved, isolating gold values into precise solutions ready for instrumental measurement.
In the ICP's bright plasma, dissolved samples are split into light, letting precise gold concentrations be read from their spectral fingerprints.
Alongside wet chemistry and plasma, X-ray fluorescence offers a rapid, non-destructive check that each finished bar truly matches its stamped fineness.
Layering instrumental results with long-term control charts, the assay chemist confirms that this batch of gold meets the refinery's strict 24-karat standard.
With the lab's signature in hand, the engineer updates the system, turning a pending batch of metal into officially released bullion. Approved bars leave their trays and stack into dense, shimmering bricks on a pallet, each stack now a certified cache of refined gold.
From the corridor, the certified bars enter the finished goods warehouse, where forklifts and racks take over from furnaces and flasks.
Carefully lifted into its assigned bay, the pallet of bars comes to rest among labeled racks, waiting under watchful lights and cameras.
With lab results logged and location confirmed, this stack of gold is fully certified and stored, awaiting.
In the finished goods warehouse, certified gold rests in labeled bays, waiting for the next call from logistics and dispatch.
With routing confirmed, the forklift retrieves a full pallet of gold, drawing it out of storage and into the path toward outbound shipment. In the dispatch zone, the stack leaves its rack and settles onto a turntable, where protective wrapping and security strapping will seal the load.
Steel bands clamp the gold into a single, locked mass, forming a secure core before the outer layers of protection go on.
Thick stretch film and numbered seals hide and lock the bullion, turning an exposed stack of bars into a tamper-evident shipping unit.
Photos and scans lock each sealed pallet into the digital manifest, creating a visual record before the load ever leaves the building.
Guided by painted lanes and bay indicators, the sealed pallet rolls toward a chosen dock, where a waiting truck will carry the gold beyond the factory walls.
Outside, a waiting truck eases back onto the dock until lights and bumpers confirm a tight seal between trailer and warehouse.
With the leveler locked and wheels chalked, a solid bridge forms from warehouse floor to trailer, ready to carry the. Inside the trailer, the sealed pallet is placed carefully at the front wall, forming the anchor point around which the rest of the load will be secured.
Heavy chocks and cross straps bind the pallet of gold tightly to the trailer, ensuring it will not
Trailer
budge.
becomes a sealed container.
74291 bolt.
With paperwork signed and digital records updated, responsibility for the sealed pallet passes from the plant floor to the open road.
From pit to pallet, the site reveals itself as one connected machine, all of its moving parts focused on.
Subscribe for more real factory breakdowns.